Hello, how you doing? Let's raise your engineering game by learning about NoSQL data stores. In this video, I will show you how to integrate AWS Lambda and DynamoDB. Amazon DynamoDB is a serverless, fast, flexible, key-value document data store service in AWS Cloud. Okay, let's get started. I'm going to give you a quick overview of what we're going to cover in this video. First, I will introduce basic DynamoDB concepts. After that, I will create a DynamoDB table. Next, I will show you how we can integrate a Lambda function with DynamoDB. After this, I will step through some additional DynamoDB features. Lastly, I will summarize some key points to take away from this video. Okay, so let's get into it. As you would expect, DynamoDB has a concept of a table. Rows in DynamoDB are called items. Items in DynamoDB are documents. Documents have attributes. Attributes are the logical equivalent of columns in a relational database table. Attributes can be scalars like numbers, booleans, binary strings. But in addition, attributes can be collections like lists or maps or sets. Every item in a DynamoDB table must have a unique primary key. There are two types of primary keys in Dynamo. They are referred to as a simple primary key and a composite primary key. A simple primary key is made up of just a partition key. A composite primary key is made up of a partition key and a sort key. The primary key is defined when you create the DynamoDB table. The partition key is also known as a hash attribute. The partition key must be a scalar value such as a number, binary, or string. DynamoDB uses a partition key in an internal data store hash function to determine the partition the data will be stored in the DynamoDB table. The sort key, if defined, is used to sort the data inside the respective partition. CRUD operations in DynamoDB are executed using the put item, get item, and delete item. You will need to provide a primary key as input to these CRUD operations. Again, the primary key could be just the partition key or the partition key and sort key if the table is configured with a composite primary key. The DynamoDB query language is very simple when you compare it to the query language for a relational database. This is where the category of NoSQL Datastore comes in. All data stores in this category do not support some flavor of ANSI SQL. In DynamoDB, the query operates over a single partition. If you have a composite key with a sort key defined, the query operation scans all the items within the partition. You can also define a filter expression to limit the results returned by the query operation. Alternatively, the scan operation does scan across the entire table. You can pass in a filter expression to limit which items the operation returns. But it's important to know that even if your filter expression returns a small number of items, the scan operation still scans and reads all the items in the DynamoDB table. This operation should be used very carefully on tables with large numbers of items. This operation can be very expensive when used with high volume data sets. So is DynamoDB a replacement for PostgreSQL or MySQL or any other relational database? No, not necessarily. The choice of database always depends on your use case. Your system requirements, your business requirements, and your use case drive the best selection of a data store. DynamoDB is better at use cases requiring web-scale workloads, requiring simpler data access patterns such as user profiles, gaming, leaderboards, IoT systems. But for use cases requiring ad hoc queries or involving transactional data, a relational database is still a better fit. Now, let's go create a DynamoDB table. In the AWS console, I navigate over to the Amazon DynamoDB homepage, click the tables link. I click the Create Table button. So in this example, I'm going to create a table to store user chat history. So this is a table, for example, you might use when building a simple chatbot application. First, I'm going to provide a table name. Then I'm going to provide a partition key called user key. Then I'm going to provide a sort key called datetime. And I'll go with all the other defaults. I click the Create Table button, and now you can see my newly created table in the DynamoDB Table Summary view. I can see the table details by clicking the table name. So now I'm going to go ahead and create the Lambda function, which will integrate with this DynamoDB table. I navigate over to the Lambda homepage. I click Create Functions button. I give my Lambda function a meaningful name. I select Python 3.8 as my language runtime. I go with all the other defaults, and I click Create Functions. The AWS Lambda service auto-generates some default code for me. I click the Test button. The first time you run a Lambda function, you need to create a test event, so I give it a name and click the Save button. I click the Test button again, and I get the Lambda function success results message. This is what I would expect. Now, I want to change some of the default configurations for my Lambda function, so I click the Configurations link. In the General Configuration section, I want to increase the timeout from 3 seconds to 15 seconds. In the Permissions section, I want to update the policies associated with the IAM role that is associated with the Lambda function, so I click on the IAM role link. I have a video covering Lambda and IAM roles, and in that video, I go into great detail on how to add policies to roles. But in this video, I'm going to keep things going quickly. So I've added the Amazon DynamoDB full access policy, this role. And what that will allow us to do is the Lambda function will be able to has permissions to interact with DynamoDB. Now with the configuration changes in place, I'm going to go back and add my Python code to my Lambda function. Under the code link, add my Python code. The Lambda handler is the entry point for this Lambda function, and this Lambda function code integrates with the DynamoDB user conversation table I created a little bit earlier. That table has a composite primary key, which means that we have a partition key and a sort key. The user key is the partition key, and datetime is the sort key. In the Python code, I have a user key variable I've set to demo user1, and the Lambda handler calls various Python functions within this function that perform CRUD operations, query operations, etc. The Python functions handle upserts, deleting, getting items, performing queries and scans against the DynamoDB user conversation table. The upsert item function will insert a new item into DynamoDB if it doesn't exist. Otherwise, it will just perform an update. For the first test I'm going to run, I comment out everything except performing upsert item and get item. I click the deploy button, which updates the Lambda in the cloud, and I click the test button. In the execution results console, I can see the logging that the code performed an upsert, and in this case, a get item back from DynamoDB. Now I'm going to go to the DynamoDB homepage and click Explore Items link. I now select the user conversation table, and now I can see all the items in the table. I can now see that we have one item. It has a user key of demo user1, and the question and answer match what we passed in the Lambda. Now, I uncomment out the second call to upsert item. In this first call, I insert a second item with the same question, but different answer, where winter is best. In the second upsert item call, I pass in the same user key and the same sort key, and this time I pass in spring is best. Since I use the same composite primary key for this item, it will perform an update. So I click the deploy button and execute the Lambda again. I can now see in the logs that it did what we expected. It inserted the second item, and then it went and updated the second item. And I can confirm that by going back over to the DynamoDB homepage, looking at the Explore Items tool, and seeing that the second item indeed has an answer, which is spring is best, which was the update. Now let's perform another test. I go ahead and comment out the second upsert item call, and I uncomment out the delete item call. Now the first upsert item function inserts a new record with the answer, all seasons are best. I click the deploy button and then execute the Lambda once again. And I can see in the logs that we insert another item. After this, we read the item back, and then we deleted that newly added item by making a call to delete item. Again, if we go back to the Explore Items tool in DynamoDB, we do a refresh, we can see indeed that that third item is not there. It got deleted. So now I will comment out the delete item call and uncomment out the query items function. The upsert item Python function inserts an item with an answer of summer is best. I click the deploy button, execute the Lambda again. The logs show that we perform the upsert item with summer is best. It then shows the results of the query. Since I specified the user key equal to demo user 1, the query operation returns all the items in that partition associated with demo user 1. So that all makes sense. Again, this can be confirmed by looking at the Explore Items tool in DynamoDB, which is all good. In this next test, I'm now going to change the user key to demo user 2. This is important because the user key is the partition key in our table. Remember, DynamoDB uses the partition key to determine which partition to use when storing the item in the table. I'm also going to uncomment out the scan function call. Now, my upsert item will insert a new item with the answer of fall is best. I click the deploy button and then run the Lambda again. In the execution logs, I see that the upsert item call inserted the new item with demo user 2. The query operation, which now was called with demo user 2, only returns one item because there's one item in the demo user 2 partition. Alternatively, the scan operation, which scans the entire table, returns back all the items, including those with user key demo user 1 and demo user 2. So this clearly highlights the differences between query and scan. Again, using the Explore Items tool in DynamoDB, we can see all the items have been inserted during this demo. The ones that we deleted are not there, obviously. So this all confirms everything that we saw in the execution logs. So now that I've shown you how to integrate with DynamoDB, there are two billing models available to you. The first is on demand. In this particular billing model, you pay for what you use. And this is a better model if you have unknown workloads or unpredictable traffic patterns. The second billing model is provision throughput. With this particular model, you define your read-write capacity per table, and you can also define auto-scaling rules. And this is better if you have consistent workloads or your workload ramp-ups, ramp-downs, or gradual. Now, there's quite a number of features I really didn't go into with DynamoDB. I just want to highlight that this is a fully managed service, so you don't have to worry about infrastructure with this particular service. DynamoDB is a key-value document data store. These documents have attributes, and you can have different attributes from item to item within the same table. Again, this is something that you really can't do with a relational database, but with DynamoDB you can. So DynamoDB is said to be schemaless because you can have different shapes of documents in the same table. It does support secondary indexes, and this allows you to improve your query performance for queries that are not based on your partition key. There are cost implications and trade-offs, but you do have this available to you with Dynamo. Of course, DynamoDB supports all the security service you know and love in AWS Cloud. Access and permissions are managed through IAM. Data is encrypted at rest. DynamoDB automatically replicates data within the same region. But if you want cross-region replication, you can configure this with DynamoDB global tables. So this is also something that's quite powerful. And finally, DynamoDB tables can be configured to stream out CDC events or change data capture events. So if you insert an item This can be configured to trigger an event. These events can be streamed to different AWS services such as Kinesis, Event Bridge, or even other Lambda functions. So again, this, if you've got a event-driven architecture, this can be a very important feature for you. So in summary, DynamoDB is a key value document data store. It's said to be schemaless, which means that items within the same table can have different attributes. It has a very, very simple query language, supporting a query operation and a scan operation. Is DynamoDB your data store for every use case? No. For web scale type use cases that have simple query patterns, such as leaderboards, IoT, gaming, Dynamo is a really good data store to consider. But for other types of use cases that require ad hoc queries, transactional data, a relational database is still probably going to be your best option in that scenario. So thank you for watching. All videos referenced in this video will be in the YouTube description. I invite you to watch other videos on my channel. If you like the way I'm packaging up this content, please consider subscribing. And lastly, we all love technology. We all love AWS Cloud. We love machine learning, AI. But don't forget to carve out some time to live in the real world. Go outside, go swimming, go hiking, go move your body. And if you do, let me know in the comments. And with that, have a great day.